Understand now method overloading and method overriding, and what are the difference between these two, how we can achieve method overloading. Actually in Java we have a concept of polymorphism, and that polymorphism we can achieve by these two ways: method overloading and method overriding. Okay, so consider there's a one class I have. Okay, I just say method overloading. Okay, and we'll say copy save dot java. Okay, now here I have one class. Class name could be anything. Suppose here I have a customer class. Okay, now inside the customer class, suppose I have a void cust, or let us say disp. Okay, in this disp method I'm not passing any argument, and just I want to have a message here that system dot out dot print line. Okay, and say no arguments. Okay, one method. Another say void disp. Here I say int n, one argument I am passing here, right? And I say here the same line I can copy again and say argument with n plus display the value of n. Okay, so you have seen that I'm writing this disp method twice now. Again I just say paste it. Can I skip like this? Can I? No. Even if I say int, so return type is different here. Still I cannot overload like this, right? If we just go for compilation, look at the code here, say java c method overloading dot java. What you're finding here that this int is already defined in customer. So just changing the return type will not help you to overload. The parameter must be different. Okay, say here int p, something like that, right? Make it void only. So n and plus p. Okay, save it here. And now say void disp, could be any other, say double n. So this time make it return type also, say double here, and I say return n into n. I'm returning the square of that. So how many disp method? 1 2 3 4. What is this? It is a method overloading, right? Now once we call this method here, if I want to call the method here, what will it do? So we can write here, what is the class? Customer, right? Customer c equal to new customer. Okay, and I can call the method disp. Okay, again I can call the method, I can pass 20 comma 80. Okay, c dot disp, I can call the 30. C dot disp, say this point, this one. But this guy is returning the double, so you have to be ready with one variable double d equal to, right? And you can print d here. So you have noticed here these are disp. I am calling disp here. again I'm calling. So once I call this disk, it will go to the first one, right? Once I say C disk 2080, it will go to the two argument here. This is the right. Once I say C disk 30, it will go to the first one, second one, this one, right? If I say C dot disk 678.78, so I'm passing float, not float. It is double, right? By default is a double in Java. If I want to float, say you have to say F. So this will go to here and say double disk, this one, right? It will go to the double disk double N and it will return the square of that. So then it is a big value. Make it here 5.5 here. Well, let me try now. So you are not getting error here. Now just compile it here. What you are finding here, you can just look it here. So first no argument, second 2080, third is 30, and 5.5 is this much, 302 point coming, right? I hope you understood here. This is what method overloading. Okay. Now let us understand the method overriding here. How we can make the method overriding. So consider, let us say method overriding. Okay, method overriding. Okay, save it here. Now go to here this place and say here class. What is that? Consider I have a shape here. Okay, class shape, and here just I write void area. I want to write the formula for finding area of shape. What is that? There's no certain formula, right? If I could have asked that what is the formula for area for rectangle, you can easily say ln to b, right? For a square, like side square, something like that. But what is for the shape? So you don't have answer here, right? Okay, it means I cannot write any body, any code for this area method, so I can go for semicolon. I don't want to write any body here, right? If I don't write the body in this case here, we'll understand more stuff rather than we'll understand method overloading also, overriding also. Now I say Java C method overriding, and you will get clear error here, missing method body or declare abstract. So you have not written the body for this method, right? So what you have to do, if you don't want to write, you have to write abstract. Okay, if you're writing abstract, then this problem is gone. But look at here, if you're having any abstract method in your class must be abstract. So shape is not abstract and does not override a abstract method area in the shape. So you have to say here also what? Abstract. So this is abstract class now. Abstract class having abstract method, right? Now, it is not like compulsory that abstract class should have abstract method. I can have a without abstract also. Well, so consider I have a void disp. One method is there, display method. Okay. which is printing some kind of result. Suppose here I declare one string and say result. Okay, and here I just print system dot out dot println and I say result. Okay, so here I have a body. Okay, now this code is fine. So what you understand abstract mean here? Like abstract class can have abstract method, can have implemented method, right? And can have only, say here, if I say like this, it can also have only implemented method. It can also have only abstract method. It can also have mixed set of methods. Could be abstract, could not be abstract. So any of the combination is possible for the abstract class, right? Okay. So when you will make abstract class, sometimes like you want to, if you have some kind of method like this is the case where we cannot write the body. So you have to make abstract method, then class should be abstract. That's the only condition. Otherwise in abstract class you can have anything. But if the method is abstract, class should be abstract. Okay. So we have made one abstract class with area and sphere, right? Now another class I have, say here class rectangle. Now I will do what extends what class shape. Now we can override here void area and we can write some kind of result equal to some formula we can write L into B, right? So let us say just I will say here rectangle. Okay, rectangle here. Similarly, we can go for circle, right? We can write the same class here and we can say here class circle, right? And I say extends shape. And again we can override the method void area and this time I can say pi r square, the formula of finding area for circle, right? So just I'm storing a result equal to circle, only the masses I'm storing here, right? Now so we have made one kind of abstract class shape which I'm extending in rectangle, which I'm extending in circle. So it is a subclass of shape here, right? Now what I'll do in a main method here, look it now. Here I can simply say rectangle r equal to new rectangle, right? And then r dot area, I can call the area method, right? And then r dot disp, I can call this method because this method is coming through the inheritance in the rectangle, right? Since I'm inheriting the shape, so I'm getting this disp method here and I can call through the object of rectangle, right? Similarly, I can do here circle c equal to new circle, right? And then c dot area, I'm calling the area method, and then say c dot disp, I'm calling the disp method. Look at the output here. No, no error, right? Now just compile this code here and say rectangle. So you're getting this output here, rectangle. Here you are getting a circle, right? So both output is coming. Then why we have made this shape here, shape abstract class? Just I'm reusing this method here, right? Just I'm reusing this variable. That is one thing. But in this code, we are saying that rectangle is a rectangle, circle is a circle. The same code we can write like this. We cannot create object of shape. I cannot say shape s equal to new shape. Look at the output or error which you get. It is saying shape is abstract, cannot be instantiated. You cannot instantiate, you cannot create object of the shape here, right? Now here I say what I can do. So this is not possible, but I can create a reference and say new rectangle. So now it is more real that because we are saying rectangle is a shape. Earlier we were saying rectangle is a rectangle, but here we are saying rectangle is a shape now. So we are giving more reality in this code here, and then we can call s dot area, then we can call s dot circle. Sorry, this method. Now the same object again I can say new circle. So I have one reference. This reference is first time pointing rectangle object, now it is pointing the circle object. Changing the reference, right? Now I say s dot area. I am calling the area here, and then s dot disp. Okay, and this is called dynamic method dispatch, right? Dynamically we are so during runtime this object is pointing to the rectangle object and working with the rectangle. Now it is pointing to the circle and working with the circle object. So it is all dynamically resolved here. We can check the output here. So it is coming twice, rectangle circle, right? So I hope you understood this stuff first of all. Now what is happening here? This area is getting overridden here, right? This area is getting overridden here. This is called overriding. So I can say here overriding, right? Because the same method area is available in shape, and again you are writing because we are getting the area method from the shape, right? So still we are giving some kind of other definitions for the area. What is this? It is override only. And this method I am reusing in the rectangle here, in the circle here, right? Even the result variable which is declared here, I am reusing in rectangle and circle. But no one can create the object of shape, right? It is very abstract. If someone say what is shape, what you will say? You cannot explain even, right? Because it is very general. Understood method overloading, method overriding here, right? Okay, so that's all.